We just finished class on Friday of week 1, and I finished sort of quickly going through this example where I was trying to find what were the days for the New York Stock Exchange where the difference between the high value and the low value for that index was at least 5% of the open value. So I was trying to find the days where the stock market was the most volatile. And I got an answer at the end of class, but the answer I got was pretty hard to read. So here was the formula that I used. And so I want to show a way that's more systematic and where it's easier to read. And I guess the trade-off is that we're going to alter the data frame as we're going. And so I added one thing to the code from class. I added this .copy, and that just prevents some warnings from showing up. I don't think it prevents any errors, just prevents some warnings that are showing up later. And so here's my data frame. I've already eliminated all of the rows other than the ones corresponding to the New York Stock Exchange. And let's make a new column in here, and let's call it difference. And to warm up, let's just set it equal to 3, for example. So you can see that now there's this new column on the end where the number 3 is. Though, like every entry in this column is the number 3. But that's not what we want to do, and like that wouldn't be a good name for difference. Instead, let's do dfnya, and then we'll say high minus low. Okay, and let's look at the data frame. Okay, so here are the differences. Okay, that seems good. And now let's make one that stands for 5% of the open. So let's call it, how about baseline? Okay, that's what I'm going to call my new column. Or this is like the cutoff. Maybe that's better. Let's call it cutoff. And this is going to be 0.05, so 5% times the open column. So for example, in this case, it should be about 25 in the 0th row. Let's check. So yep, about 25 there. Good. And now let's have a new column called keep. Okay, and unlike most of these, which are floats, okay, with the exception of the first two, the rest are floats. Okay, if you ever want to see what are the data types, in the first two, they're really strings, but pandas, I don't think ever refers to data type as a string. So here they call those string columns objects, and the others are all these 64-bit float elements. And so let's make a new one, and we'll call this keep. And this is going to be very similar to what we had up above. It's going to be very similar to this, except you can think about multiplying both sides by this open. So it's like 0.05 times open, and I want to know, is the difference greater than that 0.05 times the open? So we're going to say this is dfnya. And maybe I'll use this other syntax. So this dot syntax, that's the exact same as brackets and make it a string. And we want to know, I'll put it in parentheses, although I don't think that's necessary. Is that cutoff, is that less than the difference? Okay, and let's check what happened to the data types now. Okay, so now we have a Boolean data type at the end. And let's look at it. So now this is just like what we were seeing in class, where there was all sorts of falses, but there were about 60 trues buried inside of here. And so how can we only keep the rows that have a true in the keep column? Well, it's that same syntax. So if you go up here, it was dfnya square brackets, and then this complicated thing in the square brackets. For us, we're going to have DFNYA square brackets. We're going to have a much simpler thing in the square brackets because we built it up one piece at a time. So this is going to be from the keep column. And here are the same 66 rows that we found in class. Yep, that's all I'll say in this video. Thank you for watching.